Classification of adrenergic drugs. The adrenergic drugs are act on adrenergic receptors such as alpha 1, alpha 2, beta 1, beta 2, and beta 3 to show their pharmacological action on these receptors. On these receptors, these drugs show agonist and antagonist action on these receptors. These drugs are also called sympathomimetic drugs, which shows their action in sympathetic situations like fight or flight situations. The examples of adrenergic drugs are norepinephrine, epinephrine, and dopamine, etc. All the adrenergic drugs are related or synthesized from catecholamines. Chemistry. In catecholamine is a monoamino neurotransmitter which is an organic compound that has a catechol benzene with two hydroxy side group next to each other. Biosynthesis of catecholamine. Catecholamines are derived from amino acid phenylalanine. The amino acid phenylalanine and tyrosine precursors for catecholamine. Both amino acids are found in high concentration in plasma and brain. Here, pathway of catecholamine biosynthesis. Phenylalanine undergoes phenylalanine hydrolysis to produce L-tyrosine. Tyrosine hydroxylase produces L-dopa. L-dopa undergoes L-amino acid decarboxylation. This produces dopamine. This dopamine undergoes dopamine beta hydroxylase to produce norepinephrine. This norepinephrine undergoes phenylethanolamine and methyl transferase to give epinephrine. From this phenylalanine, all the adrenergic adrenergic drugs are synthesized. Degradation of catecholamine. The catecholamine have a half-life of a few minutes when circulating in the blood. They can be degraded by either by methylation by catechol orthomethyltransferase (OMT) or can deamination by the enzyme MAO monoamino oxidase. SAR of sympathomimetics. SAR of sympathomimetics agent can be completed under following subheadings. First one, substitution in phenylrine. The natural occurring noradrenaline has 3,4 dihydroxybenzene ring in catechol, but it has poor oral activity because it is rapidly metabolized by enzyme COMT. If we substitute hydroxy group at fifth position of phenylene ring instead of fifth position, the compound shows good oral activity. SAR of sympathomimetics. Second one, substitution at nitrogen. The receptor selectivity is depend upon the size of alkyl group present on the nitrogen. When size of alkyl group is increases from hydrogen to methyl or to isopropyl, active of alpha receptor decreases while activity of beta receptor increases. Third one, substitution on carbon in side chain. Inside chain, small alkyl groups methyl, ethyl or propyl metabolized slowly by enzymes, so they give more activity or act for longer time. Larger alkyl group metabolized rapidly by the enzyme, so they decrease the activity. Classification of sympathomimetics. The sympathomimetics are subdivided into direct actin drugs, indirect actin drugs, dual actin drugs. First one, direct actin drugs. Example, epinephrine, norepinephrine, isopropyl, phenylephrine, dopamine, dobutamine. Indirect actin drugs release noradrenaline from nerve endings. Example, amphetamine and thiramine, or inhibit noradrenaline uptakers. Example, morphine. Dual actin drugs. Example, ephedrine, pseudoephedrine.